Topic 8, transformations. A little overview before we go into the main lesson. What a transformation is, we're going to get an image and we're going to move it. We could either reflect it across the thing, we could just move it, like slide it, or we could rotate it. That's what transformation is. We're going to take that same image and we're just going to move it a different spot. That's a transformation. The image that we start off with is called the pre-image. Let's label it ABC. Then after you move it, you call it the image. So this guy over here, let's say we move this guy, we call it the image. And we do the image, that's the one that's been moved. So we usually put a little prime on all the things. So let's know that's the image. That's the one we moved. So the original one is ABC. After you move it, we'll put a little prime on there to let us know this is the one we moved. What we do is we do rigid motions. A transformation where the pre-image and image are the exact same. They're the exact same size and shape. All we're going to do is change the location. And we're going to do that by either doing a reflection, translation, or rotation. That's considered a rigid motion. If you don't change the shape or size of it, you just move it. It's called a rigid motion. The first one is a reflection. What happens there is we flip each point across a line, either an x-axis, a y-axis, or any given line to do it. In this case, this is a horizontal flip, right? We're going to flip this horizontally, that. So flip this across a y-axis. And you go from here to here. You can also flip it vertically, that. Or you can flip it across any line, this. That's a reflection. You flip it across the line. Next one's a translation. So you're just going to kind of like slide it. You can move it. We're going to slide this guy over there. So if this is our image, ABC, this will be our, if that's our pre-image, this will be our image, A prime, B prime, C prime. We're just going to move it. You can even slide it down. You can slide it horizontally, you can slide it vertically, or you could do it a diagonal. So you move it horizontally and vertically. That's what this one does. That's a diagonal slide. Or you could rotate it. When you rotate, you kind of turn the image. Here, we see this as our original image, pre-image, and it looks like we're rotating it right here. And we're rotating it that way. You can rotate it that way 90 degrees clockwise. Clockwise means it moves like a clock. If you think about a clock like this, clockwise goes this way. Rotating it this way. You see this and we rotate it this way. That's clockwise. So it's a 90-degree turn clockwise. If you want to, you can also go backwards this way, and that'd be counterclockwise. This would be 270 counterclockwise. The same thing. And you click this here. Let's say this is my original image. Let's do this one as original image, or pre-image. And then this one, looks like you could do it clockwise, I would say about 180. Or you could do counterclockwise 180. Either way works. Or counterclockwise. And you can see here, there's our center rotation, and we can go all the way around. So right here would be about 270 clockwise. It's almost a full circle, but a little back 90 degrees. Or you could say negative 90 degrees counterclockwise. So again, we'll spend a whole lesson on this. It's just a general idea of what things we could do. We could do a reflection, we could do a translation, we could do a rotation. And all these are considered a rigid motion because they don't change the size or the shape of the figure. What's a non-rigid motion? Something that changes the size or the shape. Dilation is a good example because dilation changes the shape. You go from A, B, C to something that's like twice as big, A prime, B prime, C prime. Dilation is a good example of a non-rigid motion. It changes the size or shape of it. What we're going to focus on in this chapter, in this topic, is rigid motions, things that don't change the size or shape. So we're going to reflect it, translate it, or rotate it. It keeps the shape the way it is. And our first one that we're going to focus on is reflections. With the reflection, we're going to reflect all the points across either the x-axis, the y-axis, or some other line. We'll reflect across that line to get a new image. It'll be the same image, same size and shape, just reflected, just moved to a different place. Let's start by plotting our points. A, -6, -6,7 is right there. B is -6,1, right there. C is -2,1, -2,1. There's my C. Let's connect those points. And like that. Now we want to reflect it across the x-axis. The x-axis is this line right there. We're going to flip it across that guy, that. Let's do this. I'm going to do it in blue, I guess. So all we're going to do is go the same distance away. We want to reflect it down. This is 1 away, 1 up from -6. So we're going to go 1 down from -6. That'll be my new B. Now let's keep a running tally here. Let me write our normal points. These are our pre-image. We have -6 and 7. We have -6 and 1. And we have -2 and 1. Now we're going to have our image after we change it. A prime, B prime, C prime. Our new B is at -6 and -1. My new C, we're going to go the same distance but down. Like from here, we're going to go the same distance. So it's up 1, I have to go down 1. That's my new C. And my new C looks like that -2, -1. Then we're going to do the same thing for our new A. With that -6, we're going to go up 7. So we're going to go the same thing but down 7 right there. That's my new A. Little primes. So that's the way you do a reflection. You go, okay, how far is it from the line? And then do the same thing across the reflection. 1 up, 1 down. Oh, it's 1 up, so you go 1 down. It's 7 up, we go 7 down. If we connect it, you reflect it across the line. Like that. Perfect reflection across that line. Next, can we glean anything off of this? Look at this. What happens when you reflect it across the x-axis? What happens to the points? The x's are the same, but the y's change. They go from positive to negative. We change the signs of the y's. The rule when for reflection across the x-axis is xy turns into x negative y. That's our rule. Reflect across the x-axis, we're just going to change the y's. We can use that here if I was want to graph this guy. We could go, okay, it's across the x-axis, figure out how far down, and do the same thing up. At 2, we go down 3, so we're going to go up 3. At C, we're going to go down 6. We're going to move it as x up 6. That's how you reflect across the x-axis. Or you can use a rule. And the rule is you look at these points, and all we're going to do is change the y-axis. In this case, -3 turns into 3. B, 6 -1 turns into 6 1. And then C, 5 -6 turns into 5 6. Works the same way. And then 5 6. And if we connect these points, we have our new graph. Don't forget to label it A prime, C prime, and B prime. That's how you reflect across the x-axis. You change all the y's. Now let's do the same thing for across the y-axis. This one we're going to do the same thing, but you want to reflect across the y-axis. We're going to reflect it across here this time. So we're going to use the exact same concept. If you want to reflect across there, just go to that where you find C. It's up and to the left one. So we're just going to go up and to the right one. We want to reflect across this guy. So just figure out where that matches and go the opposite distance away. So then over here at 1, B is 5 away. We're going to go back to 1 and go 5 the opposite direction. And then the same thing with A. A is 6. At 6, A is 5 away also. And then we're going to go 5 the opposite direction. So that might be a point might be off. Okay, that. If we look at our new points, we went from, we have points to this now. And look at our new points compared to our old points. This is A prime, B prime, C prime. A prime is 5 6. B prime is 5 1. And then C prime is 1 2. If you know what's happened this time, when we flip it across the y-axis, we changed all the x values this time. The rule here is if you want to do a reflection across the y-axis, we're going to go from xy in our pre-image to negative xy. Again, that just means change the sign. If it's negative, change to positive. If it's positive, change to negative. So that's the rule. Again, it might just be easier to go, okay, how far is it apart? Move it there. How far is it apart? Move it there. But that is the rule if you want to use the rule. Let's skip down for time. Same idea. Okay, let's try something interesting. Let's flip it across the line y equals x. We want to flip it across the y equals x line. Y equals x would be, right, plus 0. You start at 0, go up 1 over 1. That's going to be kind of this. That's my y equals x line. And that's what we want to flip it across. How are we going to do with this one when it's a diagonal? Well, the same concept. Let's start with the C here. You want to see how far it is from the line. What the difference is, you want to go diagonally. Or over here, it's easy because it's vertical. You just went down 1, down 4. So you just go up 4, down 7, you go up 7. On the diagonal, you got to go diagonal. The diagonal to this line, it's going to be 1 1/2. So we're just going to do the same thing on the opposite end. Half and then 1 right there. That's my new C. And we're going to do the same thing with the A. We're going to go down the diagonal. That's 1 diagonal, 2, 3, 4, 5. 5 diagonals this way. And then do the same thing on the opposite end. So 1, 2, 3, 4, 5. There's my new A. We're going to do the same thing with our B. So there's 1 diagonal, 2, 3, 3 1/2. Right, and then we're going to do the same thing on this side of it. There's my half. Then 1, 2, 3. And then this guy is the reflection across that line. Now, let's see if we can figure out anything about this one also. This point here is 6, -4. This one is 1, -2. And then this one is 1, -7. So let's put them next to each other. A is now 6, -4. B prime, right, is 1, -6. And then C is 1, -2. Look at the difference between what the image we started with and the image we got. Notice the difference here? They transpose the numbers. They switched them. The x and y get switched. That's the rule for doing it. The rule for if you want to reflect across the y equals x line is your image xy turns into, or your pre-image xy turns into the image yx. This is the pre-image. That's where you start. And then you end with the image. And actually, this is probably the one where I think it's the easiest to actually just, instead of figuring out the rest, it's just doing the math on this one. Here's my picture. And if I want to do the reflection across the y equals x line, which is again, that this line here is this line there. I actually think this is easier to do it by the math way. We're just going to switch it. That's all we have to do is flip the numbers and then plot our new numbers. -3 2, -1 6, -6 5. And then we get a graph that looks this. A prime, B prime, and C prime. There we go. I think for reflecting across the y equals x line, that's actually easier to do. When you do some of the flipping across the x and y, it's just as easy to go. Instead of doing the math on it where you have to switch all the x's or all the y's, just going, okay, reflecting across the y-axis, all we got to do is count from, okay, this guy is here, it's 4 away, let's go 4 the opposite way. This guy is right there, that is 4 this way, that's 6 this way, let's go 6 the opposite way. And then down here, we are 2 away from the y-axis where we're trying to rotate together. We got to go 2 the opposite way right there. You gotta reflect that. For me, that one's just as easy to do just by looking at it. this by going, okay, I want to flip it across this y line, just figure out how far apart each point is. But when you flip it across y equals x line, I think that one's easier to just transpose the numbers if you remember the rule. Anyway, that's the lesson.